So draw the circuit diagram and then calculate what is needed. When I write a number, it's just that means simply ohms, okay? Oh, yeah. Just make some changes. There we go. It's a 9-volt battery connected over there. It's a 9-volt battery connected over there. And we have the following resistors connected. And you need to first figure out what is the current here. That's the first job. After we get the current, then we'll talk other stuff. Okay? First you can figure out the current right there. So draw the circuit diagram and find the current at that spot. Okay? What you're supposed to do is this. Take this 4 and the 2 because if a current comes from here, it has to continue to go here. So that means obviously that is 6. 4 and 2 in series, 6. So just imagine you raise this and put 6, just draw 6 over here. If you draw 6 over here, the 6 that you're newly drawn and the 3 here are both in parallel. So you shrink it further down. So 6 and 3 in parallel, 6 times 3 over 6 plus 3 is 2. So from this point to this point, there is just one resistance here, which is 2 ohms. And on this side, the same story. 15 and 5 are in series, makes it 20. So the 20 and the 5 are both in parallel. 20 and 5 in parallel, 20 times 5 over 20 plus 5 gets you 4. So from this point to this point is a 4. From this point to this point is a 2. And that is 3. So if you track from here, how much resistance is there altogether? 3, 2, 4. The total is 9. 9 over 9 is 1 ampere. Make sense? Now, I've not touched the circuit. We did everything mentally. But if you want, for convenience, you can do this. As you do step by step, you just kind of draw a new circuit. You build a new circuit, and then you'll do like you will draw the new circuit like this is a 9 volts. That 3 is going to here, and from here to here was a 3. This one gets shrunk to a 6. See, it's shrunk to a 6, and this one is 5, and that part gets shrunk to a 20. Now you can see better. If you remove these two, this whole thing is 2, this whole thing is a 4, so now 3 plus 2 plus 4 is 9, so 9 divided by 9 is 9. Okay? Now, further questions. Now that you understood it is 9, 1 ampere there, so the current is 1 ampere. What are you going to do next? I want you to tell me what is the potential difference and current through each resistor. What is the potential difference across each resistor and how much is the current through that? So we need to discover or explore all the currents and all the potential differences across each resistor. Okay? So for example, this is 1 ampere. How much is the current through here? How much is the current through here? Current. Come on. How much is the current through here? Current. 1. Because this is 1 ampere coming in. The current that's coming in is 1 ampere. The current continues to go through it, which is 1 ampere. So until this junction, the current is going to be 1 ampere. You understand? So you know the current through this resistor. Done. Now what is the next thing we want to find out? The potential. So if I put a voltmeter here, what will it read? A voltmeter. See, a voltmeter is always connected in parallel. How much? 3 volts. Out of 9 volts, 3 volts are there. Out of 9 volts, 3 volts gone. Now what is left is 6 volts throughout the entire thing. So from this point all the way till here it is 6 volts. But now we need to find out the other parts. What is the equivalent resistance from this point to this point? This section completely. What is the equivalent resistance? 2. And how much current is going through that bunch? How much? How much current is passing through it? 1. So what's the potential difference then? How many volts? 2 volts. That means if I connect a voltmeter from here to here, it should read what? 2 volts. That makes sense or not? Because from this point to this point, the equivalent resistance is 2 ohms. And from this point to this point, what current is rushing through that point is 1 ampere. Because this current 1 ampere has to somehow come here. It's branching, but then we simplified it to one resistor of 2 ohms, right? So it's 2 ohms all together here. 1 ampere going through that combination. So the voltage from this point to this point is 2 volts. And can you see this 3 ohms is right across that? So how many volts should be here? How many volts should be there? We just discovered the potential difference from this point to this point is 2 volts. So what's the potential difference from here to here? What do you know about parallel circuits? In parallel circuits, what's common? What is common in parallel circuits? The potential difference. And in series, what's common? The current. You should know that by heart. You should know that very well. Now, isn't this 3 and this whole bunch a parallel combination? So when you know the potential difference from here to here is 2 volts, which is made up of a parallel of this and this, how many volts should be here? In parallel, the potential difference should be the same. So it is 2. Even otherwise you can understand. Look at this. Connecting this voltmeter here or dragging it and putting it here, will it make a difference? Connecting the voltmeter here or dragging it on the same wire and putting it here, will it make a difference? No, so this is 2 volts. So you can connect it. So that's 2 volts. When you know this is 2 volts, how much current is going here? How much current is running here? You know the voltage, you know the resistance, tell me the current. So it's 0.67. Right? 2 over 3, voltage over resistance gives you current. So this is 0.67. If the current is 0.67 in this segment, what should be the current here? Huh? 0.33. Because what is coming in is 1 ampere. And so 0.67 runs this way, the rest should go the other way. If 0.33 is the current running through here, how many volts is across here? If I put a voltmeter across here, what should it read? Hmm? So 0.33 amperes times 4, 1.32, but remember this is actually 0.3333 followed. If this is actually 0.333 never ending, and therefore this is going to be, or if you want to take it in fractions, that would be a nice idea also. Instead of taking it in numbers, take it as fractions. What's the current here? 2/3 ampere. Out of 1, if 2/3 go here, what should go here? 1/3. 1/3 ampere goes here. So how many volts should be across here? 4/3 volts. You get it? Because 4 times 1/3 is 4/3. And the same current is going here also. 1/3 ampere is going here also. So what is the potential difference across here if I put a voltmeter there, right there? 2 times this, so it's 2/3. So you can see this, from this point to this point, we already know that the voltage is 2. And you can see here is 4/3 and here is 2/3. Add up 4/3 and 2/3, it will be what? 2. So we've done all this on this side. Let's go to this point. What is the current that is moving at this junction? What is coming in here and what's going in here? What's the total? 1. What happens immediately? Splitting up again. It is splitting up once again, going this way and going this way. Now you need to know how much is the split. For that, what do you need to do? You have 9 volts already there, 3 lost over here, 2 lost from here to here. How much is left? 4. So 4 volts is remaining. And those 4 which should be here. So across this point and this point, the potential difference is going to be 4. So if I label these points as A, B, C, the potential difference across AB is 2 volts. And the potential difference across BC is 4 volts. Why so? Because 9, 3 out, 6 remaining, 2 out, 4 remaining. So all the 4 must be there. So it's 4 volts. If it is 4 volts from here to here, how many volts across the 5 ohms alone? If it is 4 from B to C, how many volts here? If it is 4 volts from B to C, how many volts across 5? 4. Because the whole thing is in parallel. In parallel, they'll all have the same voltage. Remember these things. And in series, they'll have the same current. See, why did I write 1/3 over here? Because the current cannot go anywhere else. In series, they have to keep going. Now that's 4. 4 and 5 ohms. What current is going this way? 4/5 ampere. If out of 1, 4/5 goes this way, how much goes this way? 1/5. See, that's how we kind of discover everything. When you know that 1/5 is going this way, how many volts will be across here? Across here, how many volts? 1/5 times 15. 3 volts. You automatically know that one should be 1 volt. You don't have to even do it, right? Because you know the total is 4, and you know this way also the total should be 4. 3 already here, should be 1 there. That's why I said you have to use a little bit of Ohm's law, definitely used really well, and you should know the concepts, and you should more, do this more like a puzzle, like you're trying to explore. But if you have the rules with you, you can explore in a better way. So if this is, now the current is the same, 1/5 ampere here. 1/5 times 5 is 1 volt. And that completes all our search. So we know all the resistors, how many volts across each, and how many, Make sense? If I put a voltmeter here, what will it be? Tell me this. I put a voltmeter there. 6. It should read 6. From this point to all the way there, it should be 6. And you can easily see this. From here to here is 2, and from here to here is 4, and it is 6. Right? You have a new problem? Take it. Draw the circuit diagram properly. Leave enough room when you're drawing it. And 100 volts battery connected to 100 ohms here, and then this 100 ohms. And then 100 here, 100 here, 100 here, 100 here. So what you need to find out is what is the current. Find the current through the battery or from the battery. Okay?
Well, so I started, since it's the whole thing, I started at the end, or like the farthest part. So right here, that's a series. So you can add that up to 200. And then I just started working my way in. And so if this back part is a parallel, so you do whatever the parallel is. And then whatever that is, you add 100 to it because now that's a series. And then you do the parallel with that, and then you add 100 to that, and then it'll come out to be 0.615.
Perfect. That's right. So what you need to do is, you can't just start off anywhere in between. You have to, like as you said, just look for which ones are in series or which ones are in parallel that you can start working with. Look from here. Is 100 and this 100 in parallel? No, these two are not in parallel because it's not connected properly. Now, is this 100 and this 100 in series? No, because there's a branching here. Is this 100 and this 100 in series? No, because of this branching. Is this one and this one in series? No, because of that branching. Is this one and this one in parallel? Because there's something in between. If you try to look at it that way, you're not able to find out anything other than this. So this is the first thing that you bump into. So what you do is you remove these two and put just 100, 200. So once you simplify once you get this simplified, it becomes 200. Now you notice that this 100 and this 200 are straight away in parallel. Because this 100 and 200 are straight away in parallel, product over sum. 100 times 200 over 100 plus 200. That will get you just one resistance. So that gives you 200 divided by 3. That's the ratio that you end up getting. So 200 times 100 over 200 plus 100 gets you that. Once you get this 200 over 3, now these two are in series, so you're going to add them up. So adding 100 to 200 over 3, you end up getting one resistor, which is 500 over 3, right? It's 500 over 3. Now once you have this is 500 over 3, and this is 100. Now they're both in parallel. Was there another one there? Oh, we are taking care of it. Yeah. So 100 and 500 over 3 in parallel. So what do you do is product over sum. So product of this divided by the sum of this gets you what? You divide this, product over sum of this gets you. I mean, I'm doing in ratios, but you can actually do it in numbers. This one gets you yeah, it is 60 something, so I'm trying to get the actual ratio. Is it 500 over 8? Check. Is 500 over 8? Okay, so that's 500 over 8. If you do the product over sum with those fractions, you should get 500 over 8. Then 500 over 8 plus 100. So you remove this whole thing. So 500 over 8 plus 100 is going to be a total of 500 over 8, which is 1300 over 8. That's what you end up getting. And so the current is going to be V over R, which is 100 divided by 1300 over 8. And that will be 8 over 13, which is 0.615 amperes. If you got that answer, right. Take another one. It should be a piece of cake. Question is this. You are given that the current here is 1 ampere. You're given the current over there is 1 ampere. So you're given that current. You're supposed to find out how much is this. It's not the same story as before. This is a different one.
You're given 1 ampere there by the 6 and there's another one.
That's it. The current that's going in this, that means if I put an ammeter here, it reads 1 ampere. That's all is given to you. Now you're supposed to just explore the entire circuit and tell me how much is V and how much is the current here, how much is the current everywhere. So I need all the voltages and all the currents through all the components in that circuit. Let me give you a head start on this so that you can conserve some time. Watch. What is given to you is this. So you start from there. How many volts is across here? 6. If the voltage is 6 across here, how much is the voltage across here? Why? Because they're both in parallel. So if it is 6 volts here and 3 ohms, what should be the current here? 2 amperes. So we discovered something. Now if the current is 1 ampere here and 2 amperes here, what should be coming from here? So you start now, start exploring. That's exactly how we explore. Keep exploring it like that. And once you explore step by step, you should be able to find out all the currents and all the voltages across everything. So here we go. So we discovered that is one, this is given to you. This is given to you. We discovered this. So what's the current here? What's the current coming here? So how many volts is across here? How many volts across here, across the 2 ohms? 6 volts. So how many volts from here to here? 6. How many volts from here to here? Another 6. So how many volts from here to here? 12. That means how many volts across this? 12. Because this 12 and this segment, they're all in parallel. Can you see that? So this is 12 volts here. And that will tell you the current here is 1 ampere. You see it? So what's the current going this way? 1 ampere. What's the current going this way? 3 amperes. So what's the current going here? 4 amperes. If the current is 4 amperes here, that should be the same current coming here. So we know the current here is 4 amperes. That means you know the current here is 4 amperes. Now you add up all the voltages all the way down. So from here to here, how many volts? 12. From here to here, how many volts? 24 volts, right? And from here to here, how many volts? 20 volts. So from here all the way back here, how many volts? This is 12, and that is 24, so 36. 36 and 20 more. 56. So that should be. You see how we discovered all this? In no time.